Hello everybody and welcome to another live stream. Today's live stream is going to be different. I'm actually going to be working on a display for a convention. I'm going to be participating in G-Anime. I just got confirmation on that. Now I have been working on this display for much longer, but I only finalized some of the designs recently. So I'm actually going to quickly go through some of the process that I do in creating these items. So some of you guys may know I do have a 3D printer and I use it a lot for prototyping and for projects like this. So I use my printer a lot. It's actually going on right now. It's printing another part. And it makes it so that I have a bit more creativity in what I want to do. Now, let me just turn off the title card so you guys can actually see the screen. There is a couple of things you need to know depending on what you're doing. So for the stuff I'm doing, I'm used to using inches because I do custom framing. But Cura and a lot of the other softwares uses the metric system. So I'm using Blender, which is open source, and because I'm using Blender, I need to change some of the settings before I even get started. Let me just see if I can move this so you can actually see the menu here. So on the top here, where you see this little circle and the cylinder, if you click on that, you can actually change your units that are preset. So for Cura specifically, I found that sending it to the metric system actually alleviated a lot of the sizing issues that I had originally when I first started in Blender. It is important to note there is a huge update coming for Blender, so some of this, or maybe a lot of it, may actually change. I know that the layout is changing in Blender and a lot of the tools are changing, so this may only be relevant for a very short period, but it may still be helpful for those of you guys who are trying to create your own items. So I'm going to change this to millimeters, because that's actually what works best in Blender. And with that, you saw that my cube actually changed size. So now it's actually set to millimeters. You can use either a ruler to do your measurements, which I actually tend to do, just because using the calipers all the time just wastes the battery, and I need the calipers for very fine-tuned adjustments for very minute sizing. There is a tolerance level for any project, and understanding your printer and what the tolerances are as well as the filament is kind of one of those really important things to know. So let me show you what I need to build. So let's see here. It's one of these. I think it's this guy here. I need a mount for this. Now let's give you some context here. So this is my current display. So these white portions / white and blue portions actually allow the shelving units to interconnect and be very stable. It was a stability that I needed to ensure because my coasters, even though they're super strong, they're actually designed so that you can actually technically throw them. Don't do it if you do buy them. But because they are so durable, I still don't want to take a chance that they might get damaged, because the whole point of giving something or selling something is that they don't get damaged. So I used cookie jars, oddly enough, that I got from the dollar store, and I used the shelving, I think they're organizers, mesh organizers, also from the dollar store. So it's actually been rebranded to Dollar Tree or the Buck or Two. And I created these white mounts that actually hold and actually tilt the cans to the perfect angle. Now, I chose these cookie jars, A, because they're steel, which means that if I need to punch holes in it, I can easily do so. But they're actually also the perfect size for these coasters. They have just enough tolerance so that when I add an insulation bag of some sort, they won't get damaged, which is super important. So there's two parts. There's the base part and then the top part. So this top part here allows this base part to actually just slide in. So it just slides right on top. It's not going to move. Unless somebody actually picks it up, it's not going anywhere. So what I am currently printing on my 3D printer is these lids. So these lids actually are once again made from TPU, so I wanted a flexible material in this case because I don't want to have to keep on replacing it. So having something that can flex rather than break is actually more important. And these lids need to flex. So this is actually attached on the side here, but getting the exact curvature and all that kind of took a bit of tweaking. But that's working. But now these all mount when they're side by side onto this bar. So this is the bar that I need to secure to this mesh. I know as a fact that I want to pretty much just stick it on and not take it off. So for this, what I'm thinking about doing, just so that I don't have to print a whole bar for this to sit on, that would be a waste of filament. I want to be able to essentially lock these corners in on either side. Now, when I'm working on stuff like this, I do have, if I can, the physical item next to me. And this essentially allows me to take quick measurements as I go. Because we have a specific shape on the ends, these are designed to interlock. All I really need to do is replicate one of those shapes. So preferably the inside shape, because that will fit a bit more closely. Because I did test these. These are a really tight fit when they're next to each other. So as long as I get that shape accurate, or as accurate as I can get it, then I know that I can actually get the distance between the different parts separately. Because I'm going to have to make two different parts, but I can reuse a lot of the elements for both of them. And literally all I want is something that just hooks on, and I'm going to use screws through the mesh to hold it in place. That's essentially what I'm planning to do. So that's the plan. When you start testing things, often you have to change things. So I normally do some quick test prints, and I only print part of it just to make sure I'm not wasting any filament at the same time. You may notice also that there's bolts in these parts. So I added bolts so that if I ever had to remove it, I could remove it and replace them still and just reprint a new part. Hopefully that never happens, but this is just in the likelihood that it does happen. I can still actually reuse this whole part. I don't have to scrap it. I can just take it off. Okay, so back to Blender. All right. So to start, essentially I'm going to take the measurements because I essentially need to create the cube for this, and I do need to use centimeters, which as a framer is kind of not what I'm used to using. So that's 14 millimeters in my case for the height. So I'm going to change this cube. So on the side, Blender has a little tab that if you click it, you can actually get the properties. Very, very useful to use. And oh, okay, there we go. So I'm going to go in the Y direction and change this to 14 millimeters, since I know that will be correct. Actually, I need to change the other side. Should be top. So that's the Z direction. So 14 millimeters. And the width needs to be 10 millimeters. So that's why. Okay, and then the thickness, for now I'm going to make it the correct thickness, just so that I have, once again, my reference. So that should be 7 millimeters. Alright, oh, wrong one. 7 millimeters. Okay. So, I'm actually going to copy this and paste this, because I have 2 dimensions I need to make. So this is where Blender does differ from SketchUp. You can't just enter your measurements in as easily. So that's, the smallest size is actually 9 millimeters. So I'm going to change the height to 9. Yeah. Yep, that one. Okay. So the reason why I created a separate cube is it's literally just for me to get the size for one of these ends. So switching to object mode, and I'm going to vertice, and I'm just going to pull this down both simultaneously here. Okay. All right. So this is the interlocking portion, and that should be accurate. So the very first thing after I've created my reference is I do start to label as quickly as possible. So I'm going to label this as key template so I know. And then this I actually don't technically need, but I'm probably going to use it instead of creating a new cube because it's already sized correctly. So I need another measurement here. So I need essentially the height. So if I go back to here, I need this height so that I know where to line it up. So there's two ways of doing it. You can either line it up from the bottom, which I'm actually going to do that instead. So that's about 15 millimeters. Okay, so that's set. Okay. You guys can kind of see where I'm at with this. Oh. Should have replaced my mouse before doing this. Come on. Okay. So this essentially is the basic shape that I need to work with. So I'm going to label this distance 0, 1, so I know that is just a reference. And now I can actually start building. So most cases I actually just end up reusing the cubes because they have the same dimensions that I need. And there's going to be two ways I can do this. So, yeah. Now, it is important when you do stuff like this that you leave it just a tiny bit of a gap. If it's too close, it's just not going to fit. Because with your printing filament tolerance, it tends to ooze out a little bit more and make things a bit tighter. In this case, it is a flexible filament, so I have a bit more leeway when I'm working, but it's still super important that I keep that in mind. All right. So I'm going to actually keep the same thickness because this thickness is actually a good thickness to work with. And I'm going to go in object mode here and bring up the face for this. Okay. Okay. Come on, mouse. You could do it. Okay. So the next stage, because I really only want to have to make this once. there's going to be two options here. So I have to create a lip that essentially bridges through the two portions. So in this case, I go to face. What I did find for extrude region is if you just want to extrude it and then move it manually, you just click it twice. And it actually solves quite a few issues that could arise. Okay, and I do have a fairly large gap, so I can make this as thick as I want, which is nice. And I'm just going to put it past that center point. Actually, I'm going to do this instead. This might be easier. Okay. So, this essentially covers this part here. So I'm going to copy that and paste it again. Once again, I just need the slightest bit of gap here. Not a huge amount, just enough. Okay. So I just hit Z on my keyboard and that makes everything transparent. And then I'm holding down Control and left mouse and clicking. And that allows me to select a large portion with the lasso. Now I'm going to delete these faces by literally hitting delete and faces, because I don't want any of the vertices to remain. But the cool thing is, when I go to edge mode, I can actually just right click this and hold down Alt and it'll select everything, and then I hit F to fill that in. So it's filled that in. I know that these should fit. So I can actually merge these two objects. As long as I've overlapped it enough, it should be fine. Yeah, it does look like it's going to be okay. There's actually another way of doing this, is that I could have technically combined the two like deleted this center portion and then combined it. I'm actually going to go for a really fast way because I don't have to worry about the geometry in this case. So I'm going to go to Boolean. In this case, I want B-mesh, and I want to union the two parts. And if you click the eyedrop on here, you can actually just click right on the object that you want to combine it with. So I'm going to hit apply. That's a bit messy for the geometry. The easy way to deal with that is, we'll see if it works, is you can normally go to decimate and make sure it's set to planar and then just hit apply. And sometimes it'll clean it up. And in this case it did not. So there is some weirdness going on. It is something you want to avoid. In this case it shouldn't cause any problems with the print. But let's go and change that. So I should actually just be able to oh yeah, there's a lot of weirdness going on here. Alright, so I'm going to delete these edges. It's going to delete a bunch of stuff that I don't want to delete, but that's fine. Let's see here. Okay, delete those. Because I can always rebuild this anyway. That's what I'm going to do in this case. Okay, before I delete that, I'm going to have to rejoin these two parts here. These two parts. Okay. So I'm just going to hit K here, and I'm going to create essentially a little bridge here if I can. Nope, didn't like that. Okay, I might have to wait until... based on what I'm seeing, there might be an extra vertex in there. Okay, let's see if we can just do this here. Okay. Yeah, so it was an extra vertex here. Edge. Oh yeah, there's an edge there. Okay. It's not the greatest geometry, but it's a little bit cleaner now. I may actually be able to use decimate now. So let's see if that... actually, if I could add this in, that would be better. 'Cause I'm pretty sure that's what's causing the issue. Yeah. Okay. Okay. Oh, it is cleaner. Still not the greatest geometry, but a lot of the weirdness that was going on in there is kind of cleaned up, which is a bit better. So that should actually print just fine. All right. So I have essentially this little part here. This would technically work, but I plan to put screws in the bottom. And because I plan to do that, it's actually easier if you add a bit of a hole in it. Now, when I print this, I am, based on this geometry, I'm actually going to change it because when you print it, if you have a flat surface, it actually helps out. So, because I don't actually need this angled. Okay. That. Actually, that's pretty good. Okay. Oh, it's a good thing I did that. It has something weird going on here. Oh, that's the original shape, I believe. Okay. Which means that this is actually not closed. There we go. Okay. Yeah, should be fine. There we go. Okay. Okay, that's looking a lot better. All right, because I'm going to turn this actually upside down when I print it. It's going to make things a bit easier. So I'm just going to save this to my desktop for now. Desktop. Actually, I'll save it. Sure, put this in here. Okay. I don't really save anything in here anymore, so let's see. Where did I save that? There we go. Mount. So I do have to make two separate ones. So, all right. So we need to create one more thing, and this actually helps a lot for the screws. So by default, the cylinder is going to be really huge. So let's make sure it actually created it. Oh, no. Okay. There we go. All right. Yeah, by default it sets it to 2 meters, which is extremely large. So I normally set it to like 2 centimeters just so I can actually see it in my view. Okay. Obviously I'm not going to keep it that size. I need this actually really tiny. Should be just big enough. Yeah, let's put... I should technically put 2 in there. I'm not. Because I want to test it out. If I can get away with just a 1, then that means I can actually save some time. So I'm going to copy and paste that and then make another one here. It just also leaves me some liberty in how I can align things a bit more. Okay, so... Okay, let me just hide this object here. Okay. So I'm setting this one to carve and difference. And you can see that it actually creates essentially a hole in here. So I'm going to copy that and then remove it and then do it the same here. So the cool thing is with your STLs, You don't actually have to finalize it. So what I can do is I can actually just export it as is currently. These essentially are just quick holes to make it easier to align the screws in through the mesh, but also it prevents it from splitting because it has actually a way to stretch out. Actually, I should probably make these just a little bit higher just in case. My screws are really long. Okay. So when I export this, it's actually going to recognize, even though I didn't actually apply this modifier to it, the Boolean, it's still going to actually save this, which is the cool thing about it. So it saves me a lot of time because I'm not constantly having to go back to an older file and then have to make the changes. I can actually just do it on the fly. So now when I export it as an STL, it should actually just automatically work. And this part here should now work for my purposes as well. When I do a test print, I may decide to extend out a base just to give it a bit more stability. If I do that, I will definitely be adding 2 more holes on either side just to help with the stability and to keep it from moving around too much. So I hope you guys found this informative. This is essentially my quick workflow for when I'm designing something that's more functional. It's really something you guys don't see me doing, if at all. And it is something actually that I do a lot, especially nowadays. If I don't have something, I just design it and build it. Now, there's always a balance between the two. So the reason why I didn't print these bins is because it was actually cheaper literally just to buy the bins already made. The same way that it was cheaper and more cost efficient just to buy the metal mesh bins. So 3D printing is kind of one of those things that, yes, it saves a lot of money, but it depends on your use case. It depends on what you're building. And waiting for days for something to print like this when I can actually get something almost that I can modify actually works better. So it's the combination of both techniques, is knowing when to use something that's already pre-existing versus creating something new. So I hope you guys like this, and I hope to see you guys soon. So thank you and take care.